today's lesson, we will discuss about the law of conservation of mass. The learning competency for this lesson is apply the principles of conservation of mass to chemical reactions. And then we have three specific objectives. Describe the atomic mass of the reactants and the products. Number 2, explain the law of conservation of mass. Then for number 3, convert unbalanced chemical equations to balanced equations applying the principle of conservation of mass. In your lower grade level, you have learned about the reactivity of some metals, and you have also seen the color changes of an indicator when tested with acids or bases. You have also learned that in chemical bonding, atoms gain stability by losing or by gaining electrons. Now in this activity, you will analyze the reactant and the product side given the chemical equations. So given these following chemical equations, you will determine which of these are the reactants and which are the products. Please write capital R for the reactant side and capital P for the product side in the box below the chemical equations. So for these equations, the reactants are the elements or the substances written before the arrow, and the substances written after the arrow represent the products. In the second learning task, please complete the following statements by choosing the correct terms written in the box. So let's answer. For number 1, a chemical equation is a chemist's shorthand for a chemical reaction. For number 2, the reactant side of a chemical equation is the starting materials or the substances entering a chemical reaction. Number 3, the product side of a chemical equation is the resulting substance after a chemical reaction. Number 4, to show combination of substances in the reactants or products, the plus symbol is used. And for number 5, the arrow symbol denotes to produce, to form, or to yield. Now, how do we determine the atomic mass of a given substance given its molar mass and the symbol or the chemical formula of the substance? So, to determine the number of atoms or the number of moles of hydrogen gas, we simply multiply the coefficient by its subscript. So that is, the coefficient is 2 times the subscript, that is also 2. So we have 2 times 2, that is equal to 4. And the unit is mole. To get the atomic mass of the hydrogen, we simply multiply the number of atoms or the number of mole, which is 4 mole of hydrogen, and then multiply that by the molar mass of the hydrogen, which is 1 gram per mole. So that is 4 mole times 1 gram per mole. So we get 4 grams. For the next two numbers, you will be the one to calculate for the atomic mass of the given substances, given the molar mass and the chemical formula. So let's continue. We answer the first question or the first given. We have here 3 molecules of oxygen gas. The molar mass of oxygen is 16 grams per mole. So what we are going to do is to multiply the coefficient with its subscript. 3 times 2, we get 6 mole of oxygen, or the number of atoms of oxygen is 6 mole. And then, To get the atomic mass of the 3 molecules of oxygen, we simply multiply 6 by the molar mass of the oxygen, which is 16 grams per mole. We get 96 grams since the unit mole will be cancelled out, or that is equal to 1. Then for number 2, we have 4 molecules of dry nitrogen, or we call this acid. The molar mass of nitrogen is 14 grams per mole. To get the number of atoms, we simply multiply the coefficient by its subscript. That is 4 times 3, we get 12 mole of nitrogen. And then to get the atomic mass of the nitrogen, we multiply the number of atoms, which is 12 mole, and the molar mass is 14 grams per mole. We get 168 grams since the mole unit will be cancelled out. Now that you have learned already how to calculate the atomic mass of a substance, let's try to apply the law of conservation of mass in calculating the total mass of the reactants and the total mass of the products. And let's try to compare the values. According to the law of conservation of mass, the total mass of the reactants must be equal to that of the total mass of the products. So let's take this number 1. We have here 2 molecules of hydrogen gas combined with oxygen gas to make 2 molecules of water. So we already know or familiar already with the chemical formula of water, that is H2O. First consideration, we must get first the molar mass. So please take note. Step 1, determine first the molar mass of each of the atom here. We have 2 atoms, hydrogen and oxygen. The molar mass of oxygen is 16 grams per mole. Hydrogen is 1 gram per mole. Then let's identify the reactants. The reactants here are the 2 moles of hydrogen gas, and 1 mole of oxygen gas, and the product is 2 molecules of water. Second step, after determining the molar mass, we get the number of atoms of every element in the reactants and the number of atoms in the products. So for the reactants, the number of atoms of hydrogen is 4 or 4 moles since we multiply 2 times 2, the coefficient with its subscript, and the second reactant is oxygen, and oxygen is 2 moles. Then for the products, we have 4 moles of hydrogen since we multiply 2 times 2, and then the oxygen is 2 moles since we multiply the coefficient with oxygen, so that is 2 moles. This equation is balanced because the number of atoms in the reactants and the number of atoms in the product are just the same. So we are now ready to calculate the atomic mass of hydrogen. We simply multiply the 4 moles by its molar mass, that is 1 gram per mole, so we get 4 grams. For the atomic mass of oxygen, we multiply 2 moles by its molar mass, that is 16 grams per mole, that is 32 grams. So the total mass of the reactants will be 32 grams plus 4 grams, we get 36 grams. Then for the product, the atomic mass of the hydrogen is 4 moles times 1 gram per mole, we get 4 grams. And then for the atomic mass of oxygen, that is 2 moles times 16 grams per mole, we get 32 grams. So that the total mass of the product is 32 grams plus 4 grams, we also get 36 grams. So you have noticed that the total mass of the reactants is equal to the total mass of the products. So in this case, the first equation is a balanced equation. So we concluded that the total mass of the reactants and the products are conserved before and after the chemical reactions. Now, how about the second equation? Zinc plus hydrochloric acid to form zinc chloride plus hydrogen gas. So, the same steps as in the first example, we will determine the molar mass of zinc, hydrogen, and chlorine. Then after that, we are going to determine the number of moles or the number of atoms of zinc, hydrogen, and chlorine in the reactants and in the products. For the reactants, the number of atoms of zinc is 1, hydrogen 1, and chlorine we have also 1. Then for the products, zinc is 1, hydrogen is 2, and chlorine is 2. So please notice that hydrogen and chlorine are not the same. So we need to balance the chemical equation by supplying the lowest possible coefficient before the chemical symbol or the chemical formula. In balancing the chemical equation, please do not change the subscript of the chemical formula because you are changing the identity of the components. So you are only allowed to use coefficient when balancing the chemical equation. So let's try to write 2 before the chemical formula of hydrochloric acid. Count again the number of the atoms. So here, in the reactants, the hydrogen is 2 and the chlorine is also 2. We multiply 2 times the chlorine, so that is 2. So we have already balanced the chemical equation and we are ready to calculate for the total mass of the reactants and the total mass of the products using the same steps as in number 1. We compute now for the total mass of the reactants and the products. For the reactants, the number of atoms of zinc is 1. We multiply that 65 grams per mole, we get 65 grams. For hydrogen, we have 2 moles times 1 grams per mole, we get 2 grams. For the atomic mass of chlorine, the number of moles is 2 moles times 35 grams per mole, we get 70 grams. Then we add all the 3 atomic masses of the 3 reactants, we get 137 grams. We do the same for the products. The number of atoms for zinc is 1 mole times 65 grams per mole, we have 65 grams. For hydrogen, we have also 2 mole times 1 gram per mole, that is 2 grams. And then for the chlorine, 2 mole times 35 grams per mole, also 70 grams. So that the total mass of the products is 137 grams. So we compare the total mass of the reactants and the products. They are both 137 grams. The second equation is balanced. So let's try another problem. Silver plus oxygen gas form silver oxide. So this equation is not balanced. In the reactants, silver is only 1, while in the product, there are 2 atoms of silver. And there are 2 oxygen in the reactants, while in the products, there is only 1. So we have to balance first the equation before calculating for the total mass. So let's try to write 2 before the silver oxide. So in the product, there are 4 silver and 2 oxygen. So you have noticed that oxygen is already balanced because in reactants, there are also 2 oxygen. However, for the silver, there is only 1 for the reactants. So we write 4 before silver. That become 4 atoms of silver. So in this way, the chemical reaction is already balanced. So the molar mass of silver is 108 grams per mole and the oxygen is 16 grams per mole. Then we solve for the total mass of the reactants and the total mass of the products. For the reactants, for silver, 4 moles times 108 grams per mole equal to 432 grams. Then for oxygen, 2 moles times 16 grams per mole, we get 32 grams. And the total mass of the reactants is 464 grams. Then we do the same with the products. For silver, 4 moles times 108 grams per mole, that is 432 grams. And for oxygen, 2 moles times 16 grams per mole, we get 32 grams. So the total mass of the product is just equal to the total mass of the reactants, which is 464 grams. So this equation is balanced. Please try answering for the remaining numbers.